Okay, Dale, but how does malware get in?
Well, that's a great question. We've already talked about how the standard user actually brings in a majority of it. But malware itself can actually be broken down into two different types. One of these is viruses, which requires human assistance, meaning I have to actually execute the file in order to get infected with the virus. We also see worms. Now, worms are automatic. They typically, as far as propagation is concerned, they don't need any human interaction. That's why they're called a worm. They start squirming throughout your network infrastructure and infecting more and more targets, all on their own. The other type of malware that we see is referred to as concealment malware. And we've talked about some of these. These are ones that actually hide themselves. We talked about rootkits back in system hacking. But basically, the concept behind the rootkit is that it's designed to hide itself by modifying the OS so it's not visible to the end user. The other type is called a Trojan. And a Trojan is simply a code that's been hidden inside of a file that you want to get. And we'll get into more Trojans in the next module. Now, when it comes to malware, this is typically deployed by what we refer to as an insider attack. An insider attack is a security breach that's caused or implemented by someone who's a part of the organization. And that could be an employee, a contractor, or, yeah, believe it or not, even IT personnel, including developers. And the reason why I include developers is because developers have this tendency, or again, it can be anybody in IT technically, they will create what we refer to as backdoors. A backdoor, which we also sometimes call a trapdoor, is simply a hidden feature or possibly a command that allows the user to actually implement a hidden feature. So the application itself would be used as normal. It performs as expected, unless somebody activates the back door, in which case the hidden feature gets activated and then the program does something that's totally unexpected or something you weren't aware of what it would do. Kind of like a Easter egg. Have you ever seen an Easter egg on DVDs or on a piece of software? Like Android's been doing Easter eggs for a long time where you can go in and look at the settings for your Android device, go down and tap rapidly on the version of Android. If it's Jelly Bean, then all of a sudden a bunch of jelly beans show up with little happy smiley faces. Now that's not anything destructive. It's just showing you that, again, here I am inside of settings and there's a hidden feature there that, again, if I activate the hidden feature, I get a little animation out of it. Now, we also have something that's called a logic bomb. A logic bomb is based off of the fact that this piece of malware is going to activate itself based off of what we refer to as a logical condition. Does anybody remember the movie Superman 2 with Richard Pryor? Okay, there's your next homework assignment. No, I won't torture you. It was really a bad show. But in the movie, Richard Pryor decides to go and learn about computers, and he becomes this big computer expert. And he figures out a way with all this money that's being transferred between banks, he's working for the bank, that he could just round up the cents between all these different transactions. And he would take the difference between the actual transaction and the rounding up and take that rounded up number and move it into his own account. And he ended up having hundreds of thousands of dollars. And back in the 80s, that was a lot of money. Well, that was a logic bomb that was going off because whenever a transaction took place, this actually took place. Many times we see it based off of time and date. And a great example of that is the famous Omega bomb. No, I'm not talking about some superhero's bomb. Omega Man! Now, this was a case back in 1996 that took place with Omega Engineering. This was actually the first federal computer sabotage case that took place. Now, what happened is there was a gentleman by the name of Timothy Lloyd, who was a network manager and administrator for Omega Engineering. And what was happening is he started getting written up for performance issues. And so he started looking for another job, but he was getting a little upset. And so what he decided to do was to create a logic bomb. He first went through and created a user account that was called 12345 that had no password and had full administrative rights. Now, Omega Engineering had the policy that all employees were to save their data, their work, all their documents to a centralized file server. And their policy said that they could not make their own backups. So he developed this logic bomb on his own workstation and then moved it to the server when he realized that he was probably going to be fired. Now, he also went and requested a backup tape from HR of all the data, and it was the most recent backup. He then went through and his logic bomb that he wrote basically said that if his account did not log in after 20 days, then to execute the following command. And it was simply to switch over to the network drive, which was the F drive, log in with a username of 12345, no password, change into the directory of public, and then run a program called fix.exe. Now, this fix.exe program was actually Deltree from the old DOS days, which allowed an administrator to delete files. And as it deleted, it first asked, "Are you sure you want to delete?" And then on the screen, it would say deleting. Well, he went through and changed it. So instead of deleting, it said fixing. And he said to delete everything. He used a /y option, which means it didn't prompt the user, "Are you sure you want to do this?" It just did yes. And then he did a wildcard, which means to delete everything. And finally, he issued a purge command, which basically makes it so that the files can't be recovered from backup. And to, quote, cover his tracks, he also erased the backup tapes. Now, here's the real kicker, is Omega Engineering did business with the United States Navy and NASA. So the Secret Service got involved on this one, folks. And when they raided his home, they found the same logic bomb on his computer where he'd been playing around with it, as well as that's where they discovered the tapes had been erased. Now, financially, Omega spent nearly $2 million to try to repair the programs and lost nearly $10 million in sales, which led to over 80 people being laid off. Mr. Lloyd was convicted of computer sabotage and was sentenced to 41 months in federal prison. Whoa, so how did these pieces of malware get in here? Well, there's several different methods for a piece of malware to get into your environment. One of them is untrusted sources for software. Not just, again, our desktop platforms, but also our mobile devices. Just this week, Apple announced that as many as 4,000 apps were infected by the Xcode Ghost malware product. But when you're searching for a piece of software for your PC, say for example WinZip, are you actually going to winzip.com or are you just doing a Google search and clicking on the first link? Well, that first link may not be the actual vendor. And so you install that piece of software. And of course, whenever end users see a pop-up like this, they always hit yes. They never hit no. Why? Because they want the software. Another way that we get in is through installation. There are many times that I go to install a program and I always select custom install. I never do a basic. I'm always watching and I never go click, 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 click. I take my time because many times the application or the vendor is generating additional revenue by installing toolbars on your PC, which then can lead to other malware infecting you. Another way is through, again, propagation. Once you get one, I guarantee you're going to start getting more. Another way is simply by not updating or running any type of I call it anti-ware, antivirus, anti-malware. Antiviruses can't necessarily get all the malware and all the malware can't get all the antivirus stuff. So not updating that stuff and running it is a huge detriment. Okay, Dale, I believe. Give me a sign. Okay, well, I'll give you a sign. Go look at your processes running on a system that you suspect is having an issue. One, does it have an icon associated to it, or is it just a process that's running? Also look at the description. Any reputable process, when the developer creates it, will list a description with it. Does the application itself or the process running live inside of the Windows or user profile directory? Because guess what? Those directories are accessed by any user on the device. Are there any weird URLs in their strings? Especially if somebody sends you a link. Oh, folks, trust me on this one. Be careful about the latest trend where people are creating shortcut links to websites. I'll show you what I mean here in just a second. And also look for any open TCP/IP endpoints where your machine's just listening on a port that you can't explain. Let me show you what I mean. So I've jumped out here to my Server 2012 R2 box, and I'm going to simply open up the Task Manager. Now the Task Manager has come a long way. I'm going to select more details. Microsoft a couple of years ago went through and bought out sysinternals, and they included a product which I still love to use to this day. It's called Process Explorer. And they've incorporated some of those same concepts here in the latest Task Manager. But I'm going to go here under my Details tab. I'll make this biggie size so we can see it. This is what I mean is, first of all, I always sort by my PID. And anything over 2000 in the PID is launched after the operating system fires up. And so that's when I would need to pay special attention. Now, I mentioned in the slides that you should check out the description. Notice the descriptions. Most of these make sense of what they are and what they're doing. I will also take one if I don't know, for example, what this particular product does, right-click on it and open the file location. Where is it going? Well, look, it's inside of the System32 directory inside of Windows. I might actually even drill into that application by going into its properties and looking at the Details tab, which gives me more information. You can see here it's done by Microsoft, in case they haven't listed anything in the Details tab, or I should say Details column. Now, notice the ones without icons. Well, these are basically applications that are running in the background to support the OS. That's why they don't have a typical icon associated to them. I would be very suspicious if anything above 2000 didn't have an icon. You can also right-click on Select to Search Online, which will open up your most current browser. And this computer's not hooked up to the internet, but based off your search preferences, it would take you and look for that particular product, and many times you'll be able to tell what that product is. So I can quickly tell here, I don't have any treats. I mean, threats. I'm getting hungry.